In our study of the first and second derivative tests, it's important to recognize that what we identify with critical point analysis is initially just whether a function, or a critical point rather, is a local optimum in some sense. And what do we mean by that? A local maximum, let's take that as our main example, it occurs at a point when the function is always larger than the function values nearby. So we have f of c here, and all the values nearby are less than that. So that would be a classic definition of the maximum. A global max is going to occur when that function value is bigger than all other possible function values. So local is distinctive, but it's possible that the function might get higher somewhere else. Local just means in the neighborhood of the critical point, everything else is lower. So we just make that distinction. Local means you're higher than your neighbors. Global means that you're higher than any other point on the graph. And of course, we can reverse that all to make it identify local and global minima instead of maxima. So it's worth noting that we can get multiple global maxima, for example, with the graph of y equals sine of x. We've got the sine graph, it goes up and down and up and down, and the points of maximum y value are shared. All of these points have the same y value. They're all higher than any other points on the graph. So these dots are all global and local maxima. What about a single global maximum but no global minimum? Well, something like, so we want a maximum, a single maximum, and then it fades down after that and then keeps going. Something like y equals negative x squared would do that nicely. It's concave down everywhere. The function is going to continue off down towards negative infinity, but there's a single critical point at x equals 0. And that would be a global and again local maximum. Global maxima are also local maxima in most cases. There's endpoints. We'll talk about that in a second. Give an example of a simple function with neither a global max nor a global min. This is pretty easy too with our inspiration from these simple polynomials. Let's take a look at y equals x cubed. Y equals x cubed goes like this and then back up. It keeps going higher and higher, so there's no single point on the graph that we can say this is the highest point, because it always goes higher if we're willing to move further right. And likewise, there's no point on the graph we can say is the absolute lowest, because we can always keep moving left and go lower than that. Another example might be y equals tan of x. There we go. And tan of x has roughly the same shape. Not 0 slope, though. It has 1 slope, like so. And then it repeats itself. And that has no single point that's always higher than the other points. No single point that's lower either. And so it has neither a global max nor a global min. So just keep in mind that we may or may not find these absolute highest points on a graph when we're looking for them. Okay, now let's introduce endpoints. All right, so let's talk about this function that we saw earlier. It had critical points at x equals 1 and 2, and they corresponded to height 7 and 8. So we had a point here and a point here. And so the function would look something like this. And this, f of x on the interval minus infinity to infinity, has one local max. It has one local minimum. Those are the two critical points. There's a local max here because it's higher than its neighbors. There's a local min because it's lower than its neighbors. But this cannot be the global minimum because the function goes down lower somewhere else. Just like this point here cannot be the global maximum because the function goes on and gets higher than that later. So no global max or min. That is only if we allow ourselves to use all the x values from minus infinity to infinity, though. If we limit ourselves, so we impose an artificial restriction, it's important to recognize that that's exactly what this is. It's an artificial restriction on the domain. Then things change, because we have our two critical points still on the interval, and then we are going to impose a limit of 2.5 here and 0. I know the function has this rough shape, and then we're going to cut it off, and we're including the endpoints here. So where is the function going to be highest on this interval? It's going to be at its highest at a critical point or at an endpoint. So that's why we make the distinction between critical points and endpoints, is that the global max on a fixed interval like this will occur at an endpoint or a critical point. And how do we know? Well, here the first and second derivative tests aren't much help because we're trying to compare alternate points. So the only thing that really will tell us is the actual function value. So we need to compare the actual y values, or in this case function values, f of x values, at these points. Okay. Now some of them are easy, we did before. They were 8 and 7 for f of 1 and f of 2. When x is 0, we get 0, 0, 0, 3. For the value of f of 2.5, we pull out our calculator, we do some typing, and surprisingly, we actually get the value 8 here as well. So let's just tune up our sketch a little bit based on that new information. We now know the value down here. This is 8, this is 7. Both of these points are at height 8. And then the graph goes down and has a value of 3 at f of 0. So what does that tell us overall? It tells us that on the interval 0 to 2.5, f has a global max. In other words, all points on the interval are lower than this point at x equals 1 and 2.5. Those 2 points share the honor of being the highest points on this limited interval here. And f of 2 is just a local minimum. It is not a global minimum because I can get lower somewhere else. And f of 0 is a global min, is the global min. On this interval, the function's decreasing, and if I cut it off at 0, I can't go any further. That's going to be the single lowest point on this entire 0 to 2.5 interval. So we're going to study the contrast between these two scenarios, this open-ended interval here, where in fact there's no global max or min, and what happened when we restrict the domain ourselves.